Kia ora koutou. Here are the first few questions from question 1 of this year's level 2 algebra paper. So we've got an algebraic fraction problem, we've got some factorising, and in the last part we have to be confident with using grouping or some other method to factorise quadratics where a is not equal to 1. Okay, so let's just go in order. There are a few different ways to do the first one. So we've got a linear algebraic fraction thing. So for me, the obvious first step is to add 3 to both sides. I'll show you another way at the end. So if we get it like this, we're really back to a year 10 problem. We're going to multiply both sides through by x plus 4. That gives us 2x minus 3 is equal to 3 times x plus 4. Expanding the right-hand side, we get 3x plus 12. So 2x minus 3 is equal to 3x plus 12. I'm going to add 3 to both sides, and I get 2x is equal to 3x plus 15. And now I'm going to subtract the 3x from both sides. So we're back to a linear equation with x's on both sides here, right? Negative x is equal to 15. Giving me x is equal to negative 15. Now I've put every single step in there. You don't have to do absolutely all of them, but I'll show you the ones that I definitely would be doing if I was sitting this exam. Well, I'd definitely be doing that one and that one and that one. I think it's probably I would go from there to there, but you've got to watch out that you don't make mistakes with signs. So it's definitely safer to put in all of the intermediate steps here. So you actually do need quite a lot of lines of working to do that question. But if you've done enough practice, that shouldn't feel like a difficult question. If you need some work going way back to basics, I've got some videos for year 9 or 10 with x on both sides, which will cover the ones like that. But algebraic fractions come up over and over in level 1 and level 2, so they're worth spending heaps of time on. Right, B part 1 I think is in some ways easier than A. We just have to factorise an expression. So we're going to look at the coefficients, at the numbers, then we're going to look at the x's and we're going to look at the y's, and we'll take out the highest common factor of each. So 6x cubed y minus 15x squared root y is equal to, well, let's first look at the 6 and the 15. The highest common factor is 3. So put down the 3. Now look at the x's. We've got x cubed and x squared. The highest common factor there is the x squared. Now look at the y. We've got y to the power of 1, and we've got the square root of y. So the highest common factor there is root y. And now we have to just match everything up. So how do I get back to 6x cubed y? Well, I have to multiply by 2 to match up the 6, and I have to multiply by x to match up to the x cubed, right? Because I've got the x squared here, so I need to have the x here. And with the y's, I need to have y, and I've got root y as my common factor, so it's times root y. Now look at the second term and do the same thing. We have to match up to minus 15x squared root y, so we need minus 5. We've already got the x squared, and we've got the root y. So that's all there is to it for that one there. Right, and the last one, we have to simplify fully, and you can see that we've got a quadratic in the denominator and a quadratic in the numerator. So I think before you start trying to factorise, the best thing to do is to look at each of those, and hopefully we're going to find a common factor. So 6x squared minus x minus 12. Well, what can I do with that? Well, let's go over the method of grouping to solve quadratics like this. Well, sorry, to factorise, not to solve. We want two numbers that times together to give me negative 72, right? So I'm taking the a and the c terms and timesing them together. And then we want two numbers that add together to give me negative 1. In other words, I'm looking for two numbers that have got a gap of 1. So let's put down the 8 and the 9 because that's going to work. So put down the 8 and the 9 and then see which one will be the negative and which one will be the positive. Well, we want the gap to be negative 1, so we're going to make the negative sit with the 9. And what that does is it tells me how to break down this term in here. I've done separate videos on factorising using grouping. So if this is not feeling really, really easy, if you're at exam revision time and you're watching this, then you need to go back and do a whole lot of examples on this method because it's really, really useful. So what have I got now? Well, I can break up the 6x squared, stays like that. I can break up the negative x into plus 8x and a take away 9x minus 12. And then I'm going to use what we call two-stage factorising to keep going from there. So the common factor here will be 2x. So 2x times 3x gets me 6x squared plus 4 here. And I'm hoping that this will come up as a common factor in here, and it does, because I have minus 3 times 3x plus 4. So that means that we can factorise that quadratic as follows. Right, we've got 2x times 3x plus 4 minus 3 times 3x plus 4. And that's going to be my numerator quadratic. Now I'm going to, just to make sure that you get the practice, I am going to do the same method for this here, although you actually can probably use what you've done in the top to do the bottom one by inspection. So I'll show you what I mean by that. I'm not sure how many people are still watching, but never mind. Okay, so 3x squared minus 5x minus 12. Now we can go and we can do all of this stuff again, but we know we're doing a simplifying question, right? So we're probably going to end up with one of these terms coming up again. We know that it won't be the 2x one because that's not going to help me get to a 3x squared. So let's give it a go at doing it by inspection. We're going to have 3x here and x here, and we want numbers that times to give me negative 12. So let's try putting down the plus 4 and now put down a minus 3 here, and we'll see if that works out. 3x squared plus 4x minus 9x. Yep, it does work. So in this case, I've got a clue from the question structure, and I don't need to go through the drama of doing factorising by grouping. If I did want to do it by grouping, though, it would go like this. Two numbers that times to give me negative 36, and two numbers that have got a gap of 5, right? So that add to negative 5. So 4 and 9 is going to be what I start off with, and then I'm going to put the negative sign with the 9 so that I generate that negative 5. But as I said, we've got enough clue that we could do that by inspection, so we've saved a wee bit of time. Putting it all back together, what we had to do here was to simplify this expression. Right, so that was my job. So let's get on with it. So we've got 6x squared minus x minus 12 over 3x squared minus 5x minus 12. The numerator factorised to give me this, and the denominator factorised to give me this. So happily, we can simplify those factors, giving us a final answer of 2x minus 3 over x minus 3. And that's as far as we can go. Thanks for watching. I will do the slightly odd number pattern with the calendar thing in a few minutes.